very busy, okay? Extremely busy. One of which was trying to find out how reference document for you guys to get that hard copy, if we could get it through the bookstore or have the bookstore order it. The other thing I tried to do was find out if I could post it on Blackboard and you guys could go directly to Blackboard. Well, you will see this lovely disclaimer on there. It has a disclaimer that says this document may be printed from the website, so you can get your own PDF and download it, which I told you is free. It takes only a couple minutes to get in there. It may not be copied, reproduced, or distributed electronically or in print without written permission. So I contacted them to find out written permission, because this is truly a reference document. It does have copyright associated with it. It is intellectual property. I have found out the reason why I cannot post it online, because the NCEES, the Center for Engineering Testing, does not necessarily own all the copyrights for all the contents in the book. They have been given permission to let people utilize it for the exams, but they do not hold the copyrights, which is why they can't allow us to just arbitrarily print it. So my recommendation for you guys is as follows. Go ahead and get your PDF copy. Definitely do so that you have it. The way to do it, and I will go back here under resources. If you go under resources in Blackboard, there it is. There is your click to go to the website. You go straight to this website. When you do it, go to my NCESS and create your account. And when you create the account, you can log in. It doesn't take very long at all to log in. And then under the useful documents, there's your reference handbooks, and you'll see a variety of reference handbooks. The reference handbook I'm referring to is the FE reference handbook, and that's where you can get your PDF copy. You may or may not need to print off all of it, but if you want an actual physical copy, the easiest way, because working with the bookstore and how they require you order from their site, it's very difficult for our bookstore to order it. So my recommendation is go order it yourself if you want the hard copy, and it's $13.95. So we're not talking a big, huge expense. Hello. Yeah, I'm working with what I've got, and I'm hoping I've got it straight, and we'll see if it works. If not, I'll figure it out with Kathy on Monday. Okay, thanks. Bye. So that's my recommendation for you. Okay? However, that all being said, the other reference I was going to point you all to, because we're going to talk about day planners and planning and doing some planning today, because I said we're doing this more as work ready. We will talk a little bit about estimations here before the end of the class, but we're actually going to do some professional development, some people development part. And I talked with the baseball guys, because the baseball guys coach actually gives them a planner. And I wanted to see what kind of planner they had. And I've also talked with Kathy Moore, who runs the PLC over on the Tonkawa campus. And I asked her what kind of planner that folks were given. Growing through my career, the planner system that we used was, I don't know if anybody ever remembers the name Franklin Quest. Franklin Quest was a calendar manufacturer, a day planner manufacturer. They got scooped up by Covey, and Covey is the guy who writes 7 Highly Effective Habits. So there's a variety of those highly effective habits. So Covey is one, that's one system. Daytimer is one system. The one that I'm going to show you is called Passion Planner. Here is the link to the Passion Planner website. You can go through, they have lots of tutorials, lots of things. I'm actually going to walk you through their Passion Planner, but I did get permission from them to allow you to have the entire 2018 Passion Planner in a PDF. I use the PDF version. I don't use the bound version. You can order the bound version if you want. I use it because I actually have a notebook that I plug it in. You can put this planner into a 3-ring binder. You can put it into a day timer if you have a day timer. You can put it into a variety of things. If someone wants Right now I've put the planner in the PDF, I've put it in their traditional version, which is an 8.5 by 11 page. There is something that's called, they call that the classic version or the classic layout. There's one that's more that 8 by 5, that 8-inch by 5-inch one. If anybody wants that one, email me and I will download that version as well so that you guys have it. But for printing purposes, the classic version works the best because your printers are more designed for that 8.5 by 11. You can clip it in and put it into a 3-ring binder. I use a different type of a binding system that actually has a different type of 3-ring punch. Daytimers do a 5-ring kind of hole punch. So, but this is the PDF version, and I did get permission, so you guys have access to the entire 2018 planner. And we are actually going to go through and look at it, and we'll start looking at it right now. So this is the planner. It's called Passion Planner. It's very similar to the Covey system. If you've ever seen the Covey system, it's very similar to the Daytimer Covey system as well. But this one's got some neat things into it. And I think it resonates more with what we see today. A little bit more of that artsy feel, a little bit more of that YouTube-y feel than the old stuffy Franklin Quest one, where you have your priority A's, your priority B's, that kind of a thing. So this one's just a little bit different. So it is subject to copyright. And the interesting thing is if you get the bound version, when you scribble in it and do your little notes and stuff, that it actually has the copyright for your property that you put in on the planner as well. So when we talk about copyright, you don't necessarily have to get a copyright registered, but you do have to reference who you're getting the information from and where that's coming from, so you get there. So I did get written permission to actually post it. So this one there's your kind of your traditional thing. So this tells you who's going to benefit, but the big thing here is it's going to help you set goals. So let's think about our goals. Most of you have at least a goal of getting through the semester alive, right? Getting through the semester alive. Maybe the goal of getting through the semester with an A, but you have a set of goals. This one will help you deal with some long-range planning, some shorter-range planning, and helping you do it. And I really like this kind of a one-page planner. So they actually ask you to start with, what's the biggest goal you would like to accomplish this year? And think about 2018. At the end of December 2018, what do you want to look at and look back at and say, I really accomplished something? One of the things that we do, and they tell us that if you have a New Year's resolution, write it down. If you have a goal, write it down. Next thing is if you have a goal, you want to share it, hold you accountable. There's a lot of different philosophies out there. But the big thing that we end up doing is on a day-to-day basis, we very rarely stop and look at the successes that we have. I tell people, write on your resume every year. I tell people, look and update that every year because you want to look at those positive things. We always end up thinking about the negative things that happen to us. We never really stop and say, yeah, I really accomplished something. I really did that. And we don't do that self-reflection. Think about what motivates you. Some of you, it's money, okay? Some of you, it's helping others. Some of you, it's competition. You want to be better than that person who's sitting next to you. Some of you's that. Some of you, it's something else. But you think about what motivates you. What's really going to make it so that you get your homework done on time? You get to work on time. What is it that you're really trying to do? Because that's also going to tell you and help you answer the question of, what kind of an engineer do I want to be? Or what kind of a professional do I want to be? Not all of you want to go into engineering school. Some of you want to do traditional science. Some of you want to be a variety of things. But think about what really motivates you. Why do you want to get up in the morning? What makes you get out of bed in the morning? Some of you are night owls, so getting out of bed in the morning is a challenge, but some of them's not that way. And then write some words of encouragement for yourself. You've got to be your best fan, all right? You really have to be your best fan, so some words of encouragement. So this gives you a way to start. Then they tell you about the story and they tell you how to stay connected. But here is a really cool one-page planning way to do it. So what I did is I took a plain piece of paper. And in the middle of that piece of paper, you write that big, hairy goal, right? The BOHAG. That big, hairy, audacious goal that you really want to be out there, your wish list. What do you want to look at? And then divide your paper up into 4 quadrants. This lifetime, those are your big, hairy, audacious goals. You know, I want to be an engineer who builds a bridge across something, or I have a friend who wants to go do she works for not really the Peace Corps, but she goes to a variety of places, and she just announced this morning that she was in a facility that was dealing with women in Iraq, smuggling them out of ISIS strongholds. So that's what she actually wanted to do. She worked for a long time. That's what she wanted to do. So think about lifetime goals. Where do you want to be down the road? Then look at your 3-year goals. For most of you, your 3-year goal is being, that senior year in engineering school, if you can possibly wing it, right? So you may be a junior in engineering school, but somewhere along that line. So maybe 3 to 5 years, looking at where do you want to be at the end of your college career. And then the 1-year goal, where do you want to be in December? And then what do you want to do within the next 3 months? Or what do you want to do by midterm? Okay? So those kinds of goals to help you kind of focus. And that really gets you focused because this planner actually has those steps kind of outlined for you so that you can look at it. And then you look at how you plan. All right? So this is kind of that planning part. There are my goals. There are the things that I want to do. And then how do you look at it? There's 3 ways to look at it. Way 1 is there's your year. It's a little harder to kind of scope out a year, but there's your year. For a lot of us, it's just looking at that basic month. And this gives you a month on a 2-page basis. So you can kind of scope out your month. How's your month going to be there? And this is where they actually have what's your kind of focus, personal focus and work focus. And for most of you, work is going to be school. School is work, right? That's your job. And then places to go, people to see, kind of wish list. And then you've got some places to put your priorities. Personal projects, work projects, and then there's some planning space down here just totally open. And then they lay it out on a per week basis. So now you can plot your schedule in there. Start looking at those schedules and looking at how those schedules are in there. So what's your focus for the week? You may have a test like next week. I will warn you. I'm going to give you another project-based learning account. I want you to find a video of straight line motion. For example, a vehicle going on a drag strip, going from 0 to whatever on a drag strip. And I'm going to have you take that video, and I'm actually going to have you do the one-dimensional motion equations associated with that video. And I've given you some tracking software, and I'll show you where that tracking software is, that video tracking tool. I'll show you where that is, and you guys can utilize that to actually map out and do the physics associated with one-dimensional motion on something real. Could be a cheetah going from 0 to whatever, could be a drag strip, whatever video you want to do, and if you want to film it yourself, if you happen to be a BMX racer, bicycle motocross racer, right, bicycle motocross, or a motocrosser, that totally up to you, but we're looking at one-dimensional motion at this time. You're going to get the same problem a week after next. It's going to be on 2-dimensional motion, good old projectile motion, basketball shots, that kind of thing. So we're actually going to do that kind of a project. So you may next week, your focus is getting that one-dimensional motion video done. I don't know. That's what your focus. And then write down the good things that happen as you go through the week. The good things that happen. Like for me, 1 week I wrote down my granddaughter was born. That was a good thing that happened. Or another good thing that happened, I got permission for the Passion Planner to be posted. So, that's a good thing that happened. Then you've got your personal to-do list, top priorities. What do you got to do? High priorities, and then the things that you just got to do on a daily basis. You got to pay your bills. Those are those kinds of pieces. And then you've got some free space to put in there. So that's how you kind of go through. I look at things on a daily basis. I look at things on a week basis. I look at things on a monthly basis. What I like about this planner is the following. At the end of the month, you do a self-evaluation. So if you get to the back at the end of the month, this is all dated, and it'll come down to this. At the end of the month is, what are the most memorable parts of the last month? What were those most memorable parts? What were the 3 biggest lessons that you learned? Could be getting my homework done 48 hours in advance because I get bonus credit, right? Could be something along that line. And then look at the past month and assess your priorities. Did they match up with your priorities? Did those things that you do, did it really match? Did it get you down that destination to that big goal, that big audacious goal that you had? That's one of those pieces. And then what was different between the past month and then the next month? So what was different? How did you grow, essentially? And what were you especially grateful for? See, the Covey system doesn't necessarily have that piece in there, which is really, really nice. And then think about 3 things you can change in order to make the next month better. And then get you along that route. And then you've got a checklist. Highlight your accomplishments, reform what you did, and set checkpoints. And then you start planning for the next month. And basically, all the leadership schools, the big, huge leadership schools, the ones that trains the Donald Trumps of the world, the ones that train the guys that had GE and GM, the ones that train your CEOs, they all say set aside time in your week to sit and think about this kind of stuff and put it on your calendar. It is important. It really, truly is important. I do mine like on Thursday afternoon because my Fridays are crazy. I do mine on my Thursday afternoon to kind of lay out what's my schedule for next week so I know how to start planning and where I'm going to fit in the time to do class prep or where I'm going to fit in the time to find out, gee, how am I going to get the permissions that I need for this? So you need to kind of start thinking about those things. And as you start doing that, then you start thinking, okay, you're not up against a deadline so much. You're not necessarily getting all that extra pressure for that deadline. So that's the planner. I'm going to ask that you guys, at least at the end of February, so let's kind of go through this for the month of February. I'm going to ask at the end of February, so around that March 2nd time frame, I'll actually post it as a due date. I want to kind of see your reflection pages, okay? And this is a do-it kind of points. I'm really not going to, your goals are your goals. I'm trying to just get you to work with the system and start dealing with that because that's how you're going to change yourself and that's how you guys are going to learn. And if I don't have that credibility or that, accountability part, that you're not getting into the habit of doing something like this, so turning it in is going to create that accountability. So that's why I want to get those 2 pages at the end of February. So you got some time to practice with it in January, But at the end of February, I want to see your 2 pages and your points are, did you do it? Okay? I may give you some feedback just to say, but again, I'm not going to criticize your goals. That's not what the purpose of this is. So just go ahead. This is for you. My thing here is just to be a coach. In this case, be a life coach. Just a little bit, rather than really kind of saying, or maybe give you tips on how to reach a goal. You guys have experience. I've spent 25 years in industry. And it would be like, think about this as a potential way to do something. So I'm not going to evaluate what your goals are. That's up to you. But I do want to create that accountability step of, I want you to turn something in to try it. All right? So that's what we're going to do there. Now, let me show you where the video tracking software is. Under resources, there's your video analysis software. It's tracker software. It's totally free. It's pretty nice. I've run it on my computer. I was trying to get it installed in the physics lab, but that virus, we have a virus shield thing in the physics lab, and we also have something that every time you log off, it drops everybody's files. So it's one of those things so that the computer doesn't get full up all the time. And so the tracker software doesn't quite work real well on that particular one. But on your own computers, it probably is going to work just fine. And it's really cool because you can actually track, put dots and have position points and things like that. And I'll show you as we get into some of the motion, you'll see some things that I've created using the tracker software. But it's totally free as well. So that kind of gives you some steps to work with. All right, I'm going to switch the camera here so we got it. One last time. Present. So it's showing up over here, maybe. Oh, no. Okay. Nope. Teacher camera. There we go. See if it goes. There we go. All right. One last time. 500 milliliter Erlenmeyer flask. It has gumdrops in it. Everybody's had the opportunity to actually see it in person. I've seen some of you sketch it. It's pretty cool. Your grade grade 10 points are freebies. If you turn in the assignment and give me a guess, that's 10 points, right? The rubric is 10 points is for the guess. So the easy 10 points. Send me a number, right? Easy 10 points. And it's probably more than one, right? I'm not going to see somebody who's going to turn in 1 in here. Okay? But the number's worth 10 points. The other 40 points out of 50 points is half of it is for your approach, however the approach is. And then half of that, the other half is for how you justified that approach to come up with your number. So where did your calculation come from? What did you use to get your calculation? That's what it is. And it's due by class time on Monday, right? And I want it emailed or uploaded to Blackboard. So if you click the assignment on Blackboard, it gives you a place to upload a file, or you can email me, okay? And if you do a handwritten calculation, you're going, how am I going to do that? Take a picture with your phone and send me the picture of your calculation, okay? That's one way you can do it. So there's the Erlenmeyer flask, and that's what we're going to do. So now I'm going to do an estimation problem for you. You'll see, I think one of the homework problems in this is estimate how many times your heart beats over the course of a year. I think that's one. A couple of the other ones that are out there, we'll kind of deal with that, but I'm going to do an estimation problem. So let's go to the document camera. So, what? If you want to buy a bag of gumdrops to get your estimate, that's totally up to you. How you do this is totally up to you. Yeah.
If we turn this in 48 hours early, do we get extra credit?
This one you won't get extra credit for doing it 48 hours early. But you do get 48 hours early. That definitely is on WebAssign. But this one, not so much. Okay. So, it's just kind of fun. All right, so in my other Physics 1 class, their assignment is to find a statement that looks like this. There are more atoms in a teaspoon of water than there are teaspoons in the Atlantic Ocean. Is this a correct statement? Is this a valid statement? And if so, how would you validate it?
Well, we know how many atoms are in teaspoon. We're just going to find out how much water is in the ocean.
Okay, so you want to know how many teaspoons are in the ocean, right? So that's the easy part is calculating the atoms in a teaspoon of water, assuming it's all water, right? Assuming it's totally water. That one, because everybody's had Gen Chem 1, right? Everybody's been through Gen Chem 1. Yeah. So most of you know about moles. Most of you know about a water molecule is two hydrogens, one oxygen, and we know about. So the big problem is, what's a teaspoon? If I know it, if I happen to be dealing in metric units, what's that teaspoon, right? But then the bigger challenge is, how do we know how many teaspoons are in the Atlantic Ocean? So where would I go to get the data?
There's a reference book or the internet.
Okay, if I'm using the internet, what's going to be a valid source of data if I use the internet? Oceanography. So if I want to use oceanography, I'm probably going to the National Ocean and Atmospheric Administration, NOAA. Okay? NOAA is probably who I'm going to go to. So I went to NOAA. I actually did go to NOAA. And NOAA tells you that the volume of the Atlantic Ocean is that happens to be NOAA's number for the volume of the Atlantic Ocean. And I figure that's a pretty reliable source. But look at your units. Your units are in kilometer cubed, right? Kilometer cubed. And if I'm dealing with a teaspoon, all right, if I deal with a teaspoon is approximately 5 milliliters. So my teaspoon is approximately 5 milliliters. My density of water, so let's do that part first. Let's do the easy part. My density of water is 1 gram per milliliter. And we end up, if I do 18 grams per mole for water, because remember hydrogen is 1, oxygen is 16, so 2 hydrogens are 2, my oxygen 16, that gives me my 18 grams per mole. Because we're doing an estimate, right? So I don't necessarily have to go to that multiple significant figures. So if I do that and I have 18 grams per mole, there's 5 grams because there's 1 gram per milliliter. There's 5 grams per teaspoon, and that gives me 0.28 moles of water. And good old Avogadro's number, 6.022 times 10 to the 23rd molecules per mole. That gives me 1.67 times 10 to the 23 molecules. But we wanted to know atoms, so I have to multiply by 3, and that gives me 5.02 times 10 to the 23rd atoms. So that's how many atoms are in a teaspoon. There's a bunch. Okay? So now I got to deal with this lovely. 1 milliliter is equal to 1 cubic centimeter. And if I do that and I get 1 kilometer cubed is equal to 1 times 10 to the 15th centimeters cubed. So that's going to give me my centimeters cubed. So when I do this number and I put it in centimeters cubed, I get 3.014 times 10 to the 23rd centimeters cubed. And 1 centimeter cubed is 1 milliliter. So this gives me 3.014 times 10 to the 23rd milliliters. And there are 5 milliliters to a teaspoon, so I divide that number by 5, and I get 6.208 times 10 to the 22nd teaspoons. So this was my atoms. This is my teaspoons. Better? That's my teaspoons. I'm off by an order of magnitude. This is 10 to the 23rd. That's only 10 to the 22nd. There's a lot more atoms in a teaspoon of water. Yeah. So there's a so you get a feel for how this is different, or how doing the estimation. You need to kind of know what your facts are. You need to kind of know what your orders of magnitude are. You need to give yourself some frames of reference. All right? And most of us don't think about centimeters cubed. We don't think about it because we grew up in inches, right? So when I'm doing conversions and I'm doing conversion factors, I got to have some conversion factors built in my head. The one I absolutely memorize and know for a fact is centimeters, 2.54 centimeters per inch. So I may do some strange calculations because I have that 2.54 centimeters per inch in my head. I also am on my physical person a frame of reference for 2.54 centimeters. So if I go back here, historically when we did units, and we looked at units in the King's area. The King would tell you that a yard was from my nose to the tip of my finger. That's a yard. Okay, that's how the King would identify a yard. Well, as we all know, all of us have little different lengths of arm, right? So that's a little harder. However, on your pointing finger, that first digit, the distance between this knuckle and this knuckle, almost on everybody, is very close to an inch. So most of us have a way of measuring an inch without too much trouble. Most men's stride, unless you're really tall, is about 3 feet or a yard. Okay, my stride's not quite like that. My stride is a little shorter. But most of us can take off steps and say that was about 3 feet. So we can step something off. And I'm in the physics lab, I can usually measure feet really quickly because my tiles in the physics lab are 1 foot squares. So I can actually look at the floor and say, all right, we're going to go, and each 3 tiles is very close to a meter, so I actually have a frame of reference to be able to get there. Most of us have a frame of reference. We can measure 100 yards pretty quick because we've all walked a football field. So we get a set of frame of reference in our head. So when you guys start doing calculations, you really need to think about what that frame of reference is. And I'll give you another one. So I'm going to write a number here. And let's go, document, camera, present. So those frames of reference are going to help us out big time as we start looking at things. So I'm going to give you a number. And without units, it's just a number, right? We don't know what that number is. 27 is an odd one, right? 27 is really a strange number. But if I tell you that this is in meters per second, most of us don't have a feel for what that 27 is. I can't tell you if that number is reasonable. I can't tell you, well, I can because I know exactly what that number is. But most of you are going, I don't have a clue what 27 meters per second is. But I can tell you, everyone in this room has a good feel for what 27 meters per second is. Everybody does. Because how many of you drive 60 miles per hour? You all drive 60 miles per hour. You all know what that feels like. That happens to be very close to 27 meters per second. So even though we're going to be using the metric system, this becomes a reasonable number if I'm looking at velocities traveled, or if I'm looking at how fast something is moving. That number is going to make a lot more sense, because if it's bigger than that, I'm going faster than 60 miles per hour. If it's significantly bigger than that, I don't think a horse is going to run 45 meters per second. Doesn't seem like a reasonable number. Okay? Because a cheetah is going to max out at about 66 miles per hour, 68 miles per hour. So you're talking about 30 meters per second. So if my cheetah calculates to be 100 meters per second, we know we got a problem. So that we've got to have that kind of frame of reference that we want to kind of keep in mind. So we got to really worry about our frames of reference and whether or not those numbers make sense. Whether or not the order of magnitude makes sense. Okay? It's going to be something that's really important. That order of magnitude number, we've really got to have out there. So that's just something to kind of keep in mind as we start going through these pieces and how that. The big thing is, also in physics, numbers have units. Because if you give me this, I have no idea what that is. It's pi, okay? And there are times that I can use 3.14 and actually mean 3.14 without units, because it's a ratio. That's okay. But if I'm trying to do a velocity, that doesn't tell me that it's a velocity. Just writing the number doesn't tell me it's a velocity. That number doesn't tell me if it's an acceleration. That number doesn't tell me if it's a force. It could be 3.14 pounds. Could be 3.14 newtons. So I am persnickety about units, because units have meaning, and that makes that number have meaning. So we want to have those pieces of units. We want to keep those things there. And it's particularly in Physics 1. As we get to Physics 2, things get a little weird, because you can't remember what makes up a volt. You really can't. You can't remember what makes up an ohm, the monitor for resistance. I'll show you, but it's not something that we typically make up and know off the tops of our head. It's just not something that we do. So let's kind of look at some units here that we're going to see. We have something that we call fundamental units. Yep. Yep.
Thank you.
There. Got it? Another question?
Thank you.
Okay. So we have fundamental units. Okay? It's fundamental units. Those are going to be things like length, time, mass, and remember, mass is different than weight. Mass is different than weight. Mass goes into weight, but mass is matter. It's the amount of stuff. Okay? We'll actually define it a little later as it's actually part of inertia. But mass is a unit. Length, time, mass. There is one more. We won't use it in Physics 1, but when I'm talking fundamental units, I want you to be aware of the other fundamental unit, and that other fundamental unit is the coulomb. And the coulomb is associated with charge. That's a fundamental unit that's out there. So length, time, mass, and charge are fundamental units. The other units are derived units. And so area is a derived unit because it's length times length. So that's going to give me length squared. That's a derived unit. Volume is a derived unit. So I've got length times height times width. So that gives me L cubed. That would be a derived unit. In most of what we are going to deal with, our unit of length is a meter. Our unit of time is a second, our unit of mass is a kilogram, and our unit of charge is a coulomb. So I have derived units. So those are, when we're going to be dealing with lots of derived units as we go forward. Be dealing with a lot of that. So let's look at density, and this is how things, how we can use unit analysis to help us. Density is defined as mass per unit volume. My units are going to be in kilograms per some volume squared, so cubed. So it could be kilograms per centimeters cubed, or it could be kilograms per meter cubed. I'm going to have mass per unit volume. One of your homework problems is going to say, just show by unit analysis that the unit on one side is equal to the unit on the other. So even though we've not done this, Newton's second law, force is equal to mass times acceleration, our unit of force in the metric system is Newton. It's defined as a kilogram meter per second squared. There we go. Kilogram meter squared. That's a Newton. That's how it's defined. Newton is a derived unit. Kilogram is a fundamental unit. Meter is a fundamental unit. Seconds is a fundamental unit. If I'm looking at F is equal to ma and I want to show that both sides are equal, mass is in kilogram, acceleration is in meters per second squared, so I get kilograms meters per second squared. I've shown that both sides of the equation have the same units. And in Physics 1, doing your unit analysis is going to save your hide. Because you will know if you've put the right equation together, because we're going to derive equations, we're going to make our own equations for certain things, so my units better balance out. I better have those units make a whole lot of sense. So your unit analysis is actually going to help you keep track of, am I on the right track? Do I have the right type of problem? So I really want to keep that unit analysis that are there. So you'll have a problem in WebAssign that says, so don't worry so much about what the equation is, just watch the units. Just play with the units and look at how the units are manipulated. Because I can't add kilograms and meters together. I can add kilograms and kilograms together for physical sense, but I can't add kilograms and meters, right? Because one's a mass and one's a distance. So I want to be able to have that piece that are there. I am not as persnickety in physics about significant figures. Significant figures have meaning. You will have one of the first assignments has a significant figure assignment. How many significant figures are there? I do think it's a little unreasonable to have 10 figures past the decimal point. That's not really what we're after. But I am not going to, really pay attention to a lot of that significant figures like we do in chemistry. Significant figures have very distinct meanings when I'm doing measurements. But for the gross numbers that we're working with in general physics right now, I'm not harping on those significant figures as much. Just be aware that we will do a couple of problems where you do have to carry out the significant figures in order to see what's happening physically. We'll do it then, but I'm not really as persnickety as I would be on a chemistry exam, because it definitely has a lot of meaning when I'm doing chemistry. So WebAssign will have some issues with significant figures, so be cognizant of that. If you run into that problem, take a picture of your answer, and I'll see if it's a rounding error, something along those lines. I do recommend that you carry at least one more significant figure as you're working through your problems. So if you write down your intermediate steps and you start calculating, make sure you have one more. Otherwise, you're going to get a rounding error in WebAssign, and WebAssign gets really kind of picky about those sort of things. So definitely want to work with that, but be cognizant of those pieces. Let's do a conversion problem, just so that you guys have seen a conversion problem in a while. Even though most of you've been in chemistry, and chemistry is all about conversion problems. So let's do seconds in 5 years. Okay, oops, go down. There we go. Number of seconds in 5 years. So, we know that we've got 5 years, and there are 365 days per year. Do I have to worry about leap year? Depends on how accurate I want my number to be. It could be once, could be twice, depending on when I start. It turns out if I'm dealing in leap years, these numbers are so big, it's so far down in the noise, I typically don't have to worry about it, right? So if I'm doing averages, doing things like that, at least for leap years, especially if I'm doing 11 or 12 or 13 years and I'm looking at seconds, it becomes like the 10th digit over that leap year makes into account. So I don't necessarily have to worry about it. Depends on my calculation, but we're not going to worry about it. We're just going to use our good old Julian year. And we've got 24 hours per day. And we have 60 minutes per hour. And we have 60 seconds per minute. So here's my unit analysis to make sure I've multiplied when I should or divided when I should. Years will cancel out. Days will cancel out. Hours will cancel out. Minutes will cancel out. And I'm left with seconds. So my unit analysis helps me with my conversion. It really helps me with my conversion. And then I'm going to show you something real quick. I'm going to switch. Okay, pull this up. Downloads, pull this up. Oh, I had it up already, okay. I thought I did, but I just didn't. Here. So getting to know your reference materials. So this is our FE manual that we just looked at. Here's the table of contents. And one of their first thing is, there are your prefixes for your units. You do have it in an appendices to your book, but there it is in your reference table. There are your fundamental constants of the universe. We love fundamental constants of the universe. They're right there, okay, that you have, your Newton's gravitational constant. And looky here, we've got a whole host of conversion factors. So if you're doing your conversion factors, here's a table of them. Okay? And what's really nice about these is because these are engineering units, you've got foot-pounds, you've got kilowatts, you've got lots of things that are there to help you out, horsepower, newtons. So you've got a lot of good conversion factors right there that those are probably some of the most common ones that you're going to have to deal with. You also have a list of conversion factors in your text in the back or on the front covers. You've got some conversion factors there. The other thing is you may want to bookmark it on your whatever browser that you're using. It's called the Engineer's Toolbox. And it's an electronic resource that has a lot of these same kinds of things, and it has some conversion calculators on there. So, that all being said, I'm going to warn you, there will be at least one test in here that you will not be allowed to have your calculator on. I will tell you ahead of time if it's the test that will not have a calculator. All right? That there will be at least one test that you will not be allowed to bring your calculator in. The question is why? Well, we got to start learning to be able to do some of that good old arithmetic in our heads again. And the other part is that particular test that I'm going to do it on, I'm more interested in how you set up the problem than actually what number you ultimately end up with. And you guys haven't done that in a while. You guys haven't done a problem where you haven't dealt with it. And as I was discussing it with my buddy at the Naval Academy, I said, you know what? We're sending a whole bunch of engineers out there that are highly dependent on their various devices, such as your cell phone, which is your calculator. It's actually a bunch of tools. I love my cell phone. It's a good tool. It's a distance finder, right? Some of you may have used it for your angle calculation for the building, because some of them, I've got a really good angle and level on my phone. It's really great. There's some really good applications. Problem is, there are people out there that they are not just part of science fiction. What happens if we have an electromagnetic pulse and it wipes out all your electronics? If we've trained a whole bunch of engineers out there that only rely on their electronics, we have a problem. The other problem, and I've had this happen to me, I have been out on a site doing well sampling, and I've had the horse step on my computer. Because horses are entirely really curious creatures. And when you're out in somebody's pasture doing a monitoring well, and the horses decide they want to come and help, because they will come and help, they will have a tendency to create chaos. Stepping on your computer when you're trying to take data is chaos. It was a very bad day. Or you drop your phone down the well. There is that. There is that. There's a lot of things. And then all of a sudden, you no longer have your device. You no longer have a means of recording. Now, luckily for me, not only did we record the data on the computer, because we were doing it at the same time, so we were doing calculations and being able to do it, I had all my paper records as well. So just because the horse stepped on the computer, it was a little bit of a hassle. It was not a good day. And you wanted to get mad at the horse, but the horse was just trying to help, So we have a lot of those things. So there will be, we're trying to get back some of those skills that we've lost. And I've said, for the Navy, if they have an electromagnetic pulse, I certainly want to be able to calculate the range and distance of my weapon that's on my ship to be able to hit the target. And I will warn you that the British Navy had a very big problem. If anybody has ever heard of the Falklands War, the British Navy actually had a big issue. They, at least at the beginning of the Falklands War, they missed every shot they shot. They were off. Anybody know why? Anybody know where the Falkland Islands are? Huh? Argentina. Where is the British Navy generally at?
Oh, it's in the northern hemisphere, and they were shooting in the southern hemisphere, so that's the reason why.
That's the reason why they didn't account for the fact that when every shot they shot went the wrong direction, because they had switched hemispheres. So their angles were off. The first Mars lander crashed. Does anybody know why?
One team used metric instead of standard or vice versa.
Yep, they used the wrong conversion factors. Does anybody know why the Hubble telescope had to be fixed? They did the wrong calculation and they had a spherical aberration. So they were off on their sphere. They sent a beautiful, well-done mirror that was off because somebody didn't check the calculation. So think about that. And those are simple things. Those are very, very simple things that we have to worry about. So that's one of the reasons that we beat these in. So we are now at 1:50. My Tonkawa is going to be off. We will see everybody Monday. Yeah.
Hey, I just want to let you know I'm almost done with that resume, so I'll have it.
Okay, not a problem.